What if everything you knew about electric cars was about to become history? Ford has been working on a secret project in a hidden lab, and the result is a battery that makes Tesla's entire lineup look like a relic from the past. Elon Musk isn't sleeping well tonight, and he shouldn't be. While the world was watching SpaceX launches and debating the Cybertruck's design, a giant was reawakening in Dearborn, Michigan. Ford, the company that put the world on wheels over a century ago, has just fired a shot that could very well end the modern EV race as we know it. This isn't about a new electric Mustang or a bigger F-150 Lightning. This is about a fundamental technological leap that makes everything else on the road, including every single Tesla, look like a horse and buggy. They've been working in secret, filing patents under cryptic names and funneling billions into a skunkworks project that most of the industry wrote off as impossible. The project? A mega-range solid-state battery. We're not talking about a 10% improvement in range. We're talking about a battery that can theoretically deliver over 1,000 miles on a single charge. A battery that can be recharged from empty to full in less than 10 minutes. A battery that is safer, lighter, and lasts longer than anything on the market today. This isn't an evolution, it's a revolution. It's the kind of breakthrough that happens once in a generation, and it completely redraws the map of the automotive world. For years, Tesla has been the undisputed king of the EV landscape, built on the foundation of its superior battery technology. But what happens when that foundation cracks? What happens when the one advantage they had over everyone else vanishes overnight? Today, we're not just looking at a new piece of tech, we're looking at the potential collapse of an empire and the rise of a new one. We're going to break down exactly what Ford has created, how they solved the unsolvable problems of solid-state technology, and what this means for you, for Tesla, and for every car company on the planet. Get ready, because the EV world as you know it is about to change forever. Before we can grasp the sheer magnitude of Ford's achievement, we need to understand why solid-state batteries have been the elusive holy grail for decades. To do that, let's quickly look at the battery in your phone, your laptop, and every Tesla on the road, the lithium-ion battery. Think of it as a sophisticated sandwich. You have two solid electrodes, the anode and the cathode, and separating them is a porous plastic layer soaked in a flammable liquid electrolyte. When you charge the battery, lithium ions travel from the cathode through this liquid swamp and embed themselves in the anode. When you use the battery, they travel back. This process has powered our world for 30 years, but it has critical, inherent flaws. That liquid electrolyte is the biggest problem. It's volatile and flammable, which is why you hear about thermal runaway and battery fires. It also limits how fast you can charge, because if you push the ions too quickly, they can form metallic spikes called dendrites. These dendrites are like tiny, sharp needles that can grow right through the separator and short-circuit the battery, potentially causing a fire. To prevent this, current batteries have complex, heavy, and expensive cooling and management systems. They also have a limited energy density, meaning you can only pack so much power into a given space and weight. This is why EV range has hit a frustrating plateau. Car makers have been making batteries bigger and cars heavier, but they haven't fundamentally changed the energy per kilogram. Now enter the solid-state battery. The concept is elegantly simple. Replace that flammable liquid electrolyte and the flimsy separator with a single, solid, stable layer. This layer, often a ceramic or a polymer, is non-flammable and acts as an impenetrable barrier. Lithium ions still travel from cathode to anode, but now they move through a solid medium. This one change unlocks a cascade of game-changing benefits. First, safety. With no flammable liquid, the risk of fire is virtually eliminated. You can theoretically puncture a solid-state cell and it won't erupt in flames. This means automakers can strip out a huge amount of the heavy, complex cooling and safety hardware, making the battery packs lighter and cheaper. Second, energy density. That solid electrolyte allows for the use of a pure lithium metal anode, which is the ultimate goal. A lithium metal anode is incredibly energy dense, far more so than the graphite anodes used in today's batteries. This is the key to unlocking massive range increases. By packing more energy into the same or even smaller space, you can get a 500, 800, or even 1,000-mile range without needing a gigantic, heavy battery pack. Your car becomes lighter, more efficient, and handles better. Third, charging speed. Dendrites are still a concern, but the solid electrolyte is far more resistant to them. This stability allows for much faster charging protocols. Imagine plugging in your 1,000-mile range EV and being fully charged in the time it takes to grab a cup of coffee, 5 to 10 minutes. Range anxiety would cease to exist. It would be faster than filling up a gas tank. Finally, longevity. The liquid electrolyte in lithium-ion batteries degrades over time, which is why your phone battery doesn't hold a charge as well after a few years. Solid-state batteries are far more stable and can endure many more charge-discharge cycles, potentially lasting for hundreds of thousands, if not millions of miles. So if they're so perfect, what was the problem? For years, scientists struggled with three major hurdles. The first was finding a solid electrolyte material that was as conductive for ions as a liquid, without being brittle or cracking under the stress of expansion and contraction during charging. The second was preventing dendrite formation even in a solid medium. And the third, and most significant, was manufacturing. Creating these delicate multi-layered ceramic or polymer cells at scale with perfect quality and at a cost that could compete with mature lithium-ion technology was considered the Mount Everest of battery science. Companies have spent billions and have only produced tiny lab-scale prototypes. Nobody had cracked the code for mass production. Until now. So how did Ford, a legacy automaker, solve a problem that has stumped the world's most brilliant battery scientists and startups for over a decade? The answer lies in a multi-pronged strategy combining strategic acquisition, material science innovation, and a radical new approach to manufacturing. It all started quietly about 5 years ago, when Ford invested in a little-known solid-state battery startup called Solid Power. While the world was focused on QuantumScape, Ford was pouring resources into Solid Power's unique sulfide-based solid electrolyte technology. This material was highly conductive for lithium ions, but was notoriously difficult to handle because it was sensitive to moisture. This is where Ford's manufacturing muscle came in. They didn't just invest money, they embedded their own top manufacturing and chemical engineers into Solid Power's labs. This collaboration led to their first major breakthrough, a proprietary microencapsulation process. They developed a way to coat the delicate sulfide electrolyte particles in a razor-thin, inert polymer shell. This shell protected the electrolyte from degradation during the manufacturing process, allowing them to use existing lithium-ion battery production lines with only minor modifications. This was a monumental leap. While competitors were trying to invent entirely new, wildly expensive manufacturing methods, Ford figured out how to use the infrastructure that already existed. This slashed their projected costs by an estimated 70%. But protecting the material was only half the battle. The second breakthrough came in the form of what they are calling a self-healing electrolyte composition. The dendrite problem, those pesky lithium spikes, was still a major hurdle. Ford's material scientists, working with researchers from MIT, developed a composite electrolyte. It's primarily the highly conductive sulfide material, but it's interspersed with a softer, almost viscoelastic polymer. When a tiny dendrite begins to form and put pressure on the solid electrolyte, this softer polymer material deforms slightly and flows into the microfissure, increasing the localized pressure and chemically signaling the lithium ions to plate more evenly. In essence, the battery actively suppresses dendrite growth before it can even start. It heals itself at a microscopic level with every charge cycle. This innovation is what allows for the insane charging speeds they are claiming. It removes the primary bottleneck that has limited charging rates in all previous solid-state designs. Finally, the third and most crucial piece of the puzzle was the anode. To get that mega range, they had to use a pure lithium metal anode. But lithium metal expands and contracts significantly during charging and discharging, which would crack a purely ceramic electrolyte. However, their composite, semi-flexible electrolyte can handle this stress. But the real genius is in the architecture. They developed what's called an anode-free cell design. The battery is assembled with no anode at all. The lithium metal anode is formed in situ during the very first charge cycle as lithium ions travel from the cathode and pleat themselves onto the current collector in a perfectly uniform layer. This process dramatically simplifies manufacturing and improves the cell's initial quality and consistency. It's a more elegant, efficient, and ultimately cheaper way to build the most energy-dense battery cell ever conceived. By combining these three pillars, a manufacturable electrolyte, a self-healing composition, and an anode-free cell design, Ford didn't just inch the technology forward, they took a quantum leap. They created a battery that is not only powerful, safe, and fast charging, but also, and this is the key point, designed for mass production from day one. This is what Tesla and others missed. They were chasing performance in the lab. Ford was chasing performance on the assembly line, and that makes all the difference. To understand the sheer panic that must be gripping Tesla's headquarters right now, you have to look at their entire business model. Tesla isn't just a car company, it's a battery company. Their primary advantage, their moat, their entire public valuation has been built on the premise that they have a significant multi-year lead in battery technology and manufacturing. Their 4680 cells, while an impressive feat of engineering, are still just an incremental improvement on conventional lithium-ion technology. They made the sandwich bigger and a bit more efficient, but it's still the same fundamental recipe with all its inherent limitations. Ford's solid-state battery isn't an incremental improvement, it's a complete paradigm shift. It's like comparing a propeller plane to a jet engine. Let's break down the existential threats to Tesla, point by point. First, the range and charging gap. Tesla has built its brand on being the longest-range EV. The Model S Plaid, their flagship, gets an EPA-estimated 396 miles. Ford is now talking about a Mustang Mach-E or an F-150 Lightning with a 1,000-mile range. That's more than double. The psychological impact of this cannot be overstated. Range anxiety, the single biggest barrier to EV adoption for the average consumer, would be completely erased by Ford, while still being a major consideration for Tesla buyers. Then there's charging. Tesla's Supercharger network has been their other massive advantage, but it's an advantage that only exists because their cars take 30 to 40 minutes to get a significant charge. If a Ford can charge to full in under 10 minutes, the need for a vast proprietary network of destination chargers diminishes. You can just top up anywhere, anytime, almost as fast as pumping gas. Ford's technology could make the Supercharger network, a multi-billion-dollar investment, strategically less relevant overnight. Second, cost and manufacturing. Elon Musk has repeatedly stated that the long-term goal is a $25,000 Tesla. The biggest barrier to that goal is the cost of the battery. Because Ford's solid-state design is safer, it requires less heavy and expensive cooling equipment, a less complex battery management system, and less structural reinforcement. Furthermore, by designing it to be built on existing lithium-ion lines, Ford has sidestepped the massive capital expenditure that a company like QuantumScape would need to build factories from scratch. Industry analysts are projecting that Ford's solid-state pack could be 30–40% cheaper per kilowatt-hour than Tesla's 4680 cells within 2 years of mass production. This means Ford could sell a 1,000-mile range car for the same price as a 400-mile range Tesla. Or, more likely, they could release a 400-mile range Ford EV that is significantly cheaper than the equivalent Tesla, completely dominating the mainstream market. Tesla's price advantage would evaporate. Third, the technology moat is gone. For years, investors poured money into Tesla stock based on the belief that they were 5 to 10 years ahead of everyone else. That narrative is now shattered. Ford's patents on their self-healing electrolyte and their anode-free manufacturing process create a new moat, and this time, Tesla is on the outside looking in. They can't simply pivot to solid-state. They would have to either license the technology from Ford, an incredibly humiliating and expensive proposition, or pour billions into their own R&D, trying to invent a competing technology from scratch, which would put them years behind. They are caught in a classic innovator's dilemma. Their entire manufacturing ecosystem is built around cylindrical lithium-ion cells. Retooling for a completely different battery chemistry and format would be a gargantuan task, costing tens of billions and taking the better part of a decade. By the time they even had a competing solid-state product, Ford would already be on their second or third generation, having captured the market. The very foundation of Tesla's empire, its technological supremacy in batteries, is no longer secure. And when the foundation begins to crumble, everything built on top of it is at risk. Ford's breakthrough won't just impact Tesla, it's a seismic event that will send shockwaves through the entire global automotive industry, from Stuttgart to Seoul to Shanghai. Every major automaker has billions of dollars and decades of future planning invested in their current EV strategies, all of which are based on lithium-ion technology. Ford's announcement renders those plans obsolete. Let's consider the other legacy automakers like General Motors and Volkswagen. Both have invested heavily in their own battery platforms. GM with its Ultium platform and VW with its unified cell strategy. These are massive, multi-billion-dollar commitments designed to last for the next decade. Now they face a horrifying choice: continue down their current path and try to compete with a technologically inferior product, guaranteeing them a permanent second-class status in the EV market, or write off their massive investments and start a desperate, expensive race to catch up to Ford's solid-state tech. It's a lose-lose situation. Their stock prices will take a beating as investors realize their expensive EV roadmaps now lead to a dead end. Then you have the Japanese automakers, particularly Toyota. Toyota has been famously skeptical of a full-scale pivot to battery electric vehicles, investing heavily in hybrids and hydrogen fuel cells instead. They have also been one of the leaders in solid-state battery research, holding more patents than almost anyone else. However, they've always maintained that the technology was at least a decade away from commercial viability. Ford's ability to crack the manufacturing code puts immense pressure on Toyota. They are now in a sprint to commercialize their own lab-based technology, a race they are unexpectedly losing. If they can't bring their own solid-state batteries to market within the next couple of years, they risk being left behind entirely, a tragic irony for a company that pioneered electrification with the Prius. The most fascinating dynamic, however, will be with the Chinese EV giants like BYD, NIO, and CATL. China currently dominates the global battery supply chain, particularly for lithium-ion components like cathodes and anodes. Ford's technology could disrupt this dominance. While their cells will still require lithium, the shift to a different electrolyte and anode technology could reshuffle the deck on material sourcing and processing. The company that controls the intellectual property and manufacturing know-how for viable solid-state batteries will control the future. This could trigger a new kind of technological Cold War, with governments stepping in to protect their domestic auto industries. We could see massive government subsidies poured into solid-state research in China and Europe as they try to counter Ford's sudden advantage. The geopolitical implications are massive. For decades, global power has been tied to oil reserves. In the New World, it will be tied to battery technology. By making this leap, Ford hasn't just given an American company the lead, it has potentially shifted the center of gravity for the entire 21st century transportation industry back to the United States. Every single car company on Earth is having emergency board meetings right now. Their 10-year plans have turned to dust. The entire landscape has been reset, and there's a new king of the hill. The question for all of them is no longer, how do we catch up to Tesla, but rather, how in the world do we survive Ford? Now, it's easy to get swept up in the revolutionary headlines and groundbreaking claims, but as with any world-changing technology, we have to inject a healthy dose of skepticism. Is this Ford mega-range battery truly the silver bullet we've been promised, or is it just sophisticated vaporware designed to boost stock prices? Let's address the major counter-arguments and potential hurdles head-on. The first and most obvious question is scalability. It's one thing to produce a perfect battery cell in a controlled lab environment. It's another thing entirely to mass-produce millions of them from multiple vehicle lines with perfect quality control and at a low cost. This is the valley of death where countless battery startups have perished. Ford claims their technology is designed for existing production lines, which is a huge advantage. However, they will still need to secure vast new supply chains for the raw materials in their proprietary solid electrolyte. The global demand for specific types of lithium, sulfides, and polymers will skyrocket. Can the mining and chemical industries scale up fast enough to meet Ford's aggressive production targets? Any bottleneck in this new supply chain could lead to significant delays and cost overruns, pushing the timeline for these vehicles back by years. The second major concern is real-world performance and durability. Lab data is one thing, performance after 5 years of enduring harsh winters, scorching summers, bumpy roads, and thousands of fast charge cycles is another. While the theoretical longevity of solid-state cells is high, how will Ford's specific chemistry hold up? Will the self-healing mechanism continue to work effectively over 200,000 miles? Will we see unexpected degradation in certain climates? There are no shortcuts for long-term testing. Ford will have to put millions of miles on test fleets to validate their claims, and any unforeseen issues could set them back significantly. The third point of skepticism is the cost. While Ford projects a 30–40% cost reduction at scale, what will the cost be for the first generation of vehicles? New technologies are almost always expensive to begin with. Will the first solid-state Ford EVs be high-end, six-figure halo cars, or will they truly be affordable for the mass market? If the price is too high initially, it could slow adoption and give competitors a window of opportunity to catch up. The at-scale cost is meaningless if you can't survive the initial high-cost phase of the production ramp. Finally, there's the Tesla factor. We should never, ever underestimate Tesla and Elon Musk. They have access to some of the brightest battery engineers in the world and a corporate culture that can pivot with breathtaking speed. It is entirely possible that they have their own secret solid-state program that is further along than anyone realizes. They could be just months away from their own breakthrough announcement. Or they could find a different path entirely, perhaps a breakthrough in lithium-ion chemistry or a new technology like sodium-ion that offers a good enough alternative at a fraction of the cost. To declare Tesla obsolete is a bold claim, and the company has a long history of proving its doubters wrong. While the evidence for Ford's breakthrough is compelling, it's crucial to remember that we are still in the early stages. We need to see these batteries in production vehicles, independently tested and reviewed, before we can declare the war is over. The path from a lab breakthrough to global market dominance is fraught with peril, and Ford still has a mountain to climb. The promise is incredible, but the execution will be everything. Let's bring this down from the corporate boardrooms and chemistry labs to the street level. What does this technology actually mean for you, the person who buys, drives, and lives with a car every day? The implications are nothing short of transformative and will redefine our relationship with personal transportation. The most immediate and obvious change is the complete annihilation of range anxiety. The psychological barrier that has prevented millions from even considering an EV will simply vanish. Imagine a future where your car's range is so vast that you only think about charging it once or twice a month for daily commuting. Road trips will no longer require meticulous planning around charging station locations. You can just get in your car and drive, just like you would with a gasoline-powered vehicle. A trip from New York to Miami could be done with a single 10-minute charging stop. This isn't just a convenience, it's freedom. It makes EVs practical for everyone, not just homeowners with a garage charger or people living in dense urban areas with robust charging infrastructure. This also fundamentally changes the used car market. A common fear with buying a used EV is battery degradation. A 10-year-old Tesla might have lost 15–20% of its original range. Because solid-state batteries are projected to last for hundreds of thousands, if not over 1 million miles with minimal degradation, a used EV will become a much more attractive and reliable investment. A 5-year-old solid-state Ford could have virtually the same range as it did on the day it was new. This will dramatically improve resale values and make the total cost of ownership for EVs even lower. The design of our vehicles will change as well. For years, EV design has been dictated by the need to accommodate a massive, heavy, and bulky lithium-ion battery pack. With the higher energy density of solid-state technology, car designers will have newfound freedom. Cars can be made lighter, leading to better handling, braking, and efficiency. Interior space can be reclaimed, as the battery pack itself could be smaller and shaped more flexibly. We could see the return of smaller, more agile sports cars that are fully electric, or more spacious and comfortable family vehicles without the compromises currently required. Beyond the cars themselves, this will reshape our cities and infrastructure. If charging takes only 10 minutes and is needed far less frequently, the pressure to build millions of Level 2 chargers in parking garages and on city streets is reduced. The focus can shift to building ultra-fast charging hubs along major highways, similar to today's gas stations. This could accelerate the transition to EVs by simplifying the infrastructure challenge. Your relationship with energy will also change. With vehicle-to-grid (V2G) technology, a car with a massive, durable solid-state battery becomes more than just transportation. It becomes a mobile power plant. During a blackout, your Ford F-150 could power your entire house for over a week. Fleets of these vehicles could be used by utility companies to stabilize the power grid during peak demand, paying you, the owner, for the use of your battery. Your car will no longer be just a liability that costs you money, it will be an asset that can earn you money. In essence, Ford's solid-state battery doesn't just create a better electric car, it creates a better car, period. It removes the compromises and creates a vehicle that is cheaper to own, more convenient to use, more reliable long-term, and better for the environment, all without sacrificing performance or freedom. This is the tipping point. This is the moment where the electric vehicle stops being an alternative and becomes the obvious, superior choice for almost everyone. What do you think about this future? Are you ready for it? Let me know your thoughts in the comments. We are standing at a pivotal moment in automotive history, a moment that will be discussed and analyzed for decades to come. The era of lithium-ion dominance, an era defined and led by Tesla, appears to be coming to an abrupt and dramatic end. Ford, the company that started the last automotive revolution, has positioned itself to lead the next one. Their development of a manufacturable, high-performance, mega-range solid-state battery is not just another step forward in EV technology. It is a quantum leap that redefines what is possible. It addresses the core weaknesses of electric vehicles: range, charge time, cost, and longevity in one fell swoop. The technology promises to democratize electric mobility, making it a viable and superior option for every driver, not just early adopters. We've dissected the technology, we've explored the catastrophic implications for Tesla and the global auto industry, and we've envisioned the incredible new future this unlocks for us as consumers. The challenges of scaling production and proving real-world durability are significant, and we should not underestimate the competition's response. But the die has been cast. The solid-state era has begun, and Ford is holding all the cards. The narrative of Silicon Valley disrupting Detroit is about to be flipped on its head. The old guard has learned to innovate at the speed of tech, combining its century of manufacturing expertise with cutting-edge material science to create something truly revolutionary. The coming years will be a fascinating, brutal battle for supremacy. Can Tesla pull a rabbit out of its hat and counter this threat? Will other automakers be able to license the technology or develop their own in time to survive? One thing is certain: the consumer is the ultimate winner. We are on the cusp of a new age of faster, cheaper, safer, and longer-ranging electric vehicles than we ever thought possible. The future of the automobile is electric, and thanks to a reawakened giant in Michigan, that future has just arrived. If you found this deep dive valuable, make sure to hit that like button and subscribe to the channel for more content that breaks down the technologies shaping our world. And I want to hear from you one last time. Comment below. Do you believe this is the end of Tesla's reign? Is Ford the new king of EVs? Let the debate begin.